Welcome back to Section 3 and 4, Lesson 1, Video 3. Here we're going to look at some more problems as they pertain to linear functions. So I want to start by making a connection between slope and rate of change, because rate of change is something that was explored in the last unit. It is defined to be the change in the dependent variable divided by the change in the independent variable, where the dependent variable is y and the independent variable is x. Now if we compare that to the definition of slope, which is rise over run, with rise being the change in the y values and the run being the change in the x values, you can certainly see how they share the same basic idea. So while they are different, it is important to make that connection between the two. Now when we looked at slope previously, we've been finding slopes of lines and equations that have no meaning or context behind the x and y variables. But now we'll look at some situations that can be modeled using linear relations. So example 1 says, Garrison walked 2 kilometers in 40 minutes before turning around and walking 1.5 kilometers in 30 minutes. What is their rate of change? So again, rate of change is defined to be the change in the dependent variable over the change in the independent variable. So we need to figure out which is which. So let's consider what variables we have. We have the distance walked, and then we have the time. So the dependent variable in this case would be the distance, and independent would be the time. So now we can plug them into our formula. So the two distances we have here are 1.5 kilometers and 2 kilometers. So we can subtract those. And for the times, we have 30 minutes and 40 minutes. So we can subtract those as well. So if we subtract them, we get negative 0.5 kilometers over negative 10 minutes, which simplifies to 0.05 kilometers per minute. So every minute, they walked about 0.05 kilometers. So being able to interpret and determine slope is going to be helpful when we need to represent a situation with a linear equation. So let's have a look at example 2. A slide measures 15 feet high and 9 feet wide. What is the slope of the slide? So slope is rise over run. Now since we're told that the slide is 15 feet high, that would be the rise, and it's 9 feet wide, that would be the run. And we can simplify that to be 5 over 3. Now one of the main differences between slope and rate of change is that slope don't have any units, but there's still meaning behind it. 5 over 3 means that for every 5-foot drop, they travel 3 feet horizontally. So now in this example it says, express cabs charge $2.25 per kilometer plus an initial charge of $6. We have to write an equation that represents the total cost for k kilometers. So now since it's $2.25 per kilometer, it would be $2.25 times k, and then we have to add on the initial charge, giving us c equals 2.25k plus 6. So now let's compare that to y equals mx plus b. So you can see that the slope in this case would be 2.25. That's the rate at which the cost is changing. Whereas b, the y-intercept, is 6. How much was added on? It was the initial amount. So now part B of this question says, use your equation to determine how much it would cost if a passenger travels 12 kilometers. So in our equation, k represents the number of kilometers. So we'll replace k with 12. So now we need to multiply 2.25 times 12, which gives us 27. Adding 6 to that gives us 33. So now we should answer the question with a statement, since it's a word problem. So we can say that it would cost $33 for a 12-kilometer cab ride. So now part C says, if a passenger paid $53.25, how far did the cab travel? So in our equation, C represents the cost. So that's where 5325 needs to go, on the left. So now we need to find out k, the number of kilometers. So we need to isolate k by bringing the plus 6 over to the other side. And when we do that, it becomes 5325. Subtract 6. Working that out gives us 4725. Now, to get rid of the 225 in front of the k, we can divide both sides by 225, giving us 21. So now we can say that the cab traveled 21 kilometers. Now in this last example it says, Prue had 43 comics in their collection. After their weekly allowance, they would buy 2 new comics. Write an equation to represent the total number of comics, T, after n weeks. So we can write this as T equals 2n plus 43. Where the 2 comes from the fact that they buy 2 new comics every week. That's how much it's changing by. And 43 is how much they had initially. They had 43 comics to start. So now, if they continue to buy 2 comics each week, when will they have 99 comics? Now in our equation, T represents the total number of comics. So we'll replace T with 99. So now if we need to solve for n, I'm going to bring that plus 43 over to the other side to make it minus 43. And then I'll divide both sides by 2 to figure out what n is. And when I do that, I get n equals 28. So that means that after 28 weeks, Prue will have 99 comics. So that is the last video. You can now move on to the next activity in this lesson.